Let's talk about pressure. Pressure is the amount of force applied to a given area, measured in Pascal. The SI unit of pressure is Pascal. A Pascal equals force of 1 Newton over an area of 1 meter squared. So the formula is P equals F over A. F is force, A is area. So the more force you can apply to an area, the greater the pressure. It has a reverse relation with area. So the smaller the area, the greater the pressure. That's why, for example, with a little push, a pin goes into the skin of our hand, which means when the area is little, a needle can easily go into our skin. But a nail, it is difficult for a nail to go into our skin. So the smaller the area, the greater the pressure. Okay. This is an example. You have a force of 10 Newton on an area of 2 meters squared. What would be the pressure? What would the pressure be? So area is 2 meters squared. Force is 10 Newton. What is the pressure? Pressure is force over area. So pressure is 10 over 2, which is 5 Pascal. Because both force and area are in SI units, no unit change is needed. So I need to emphasize that Pascal is the same as Newton per meter squared. If we want to think of Newton as joule per meter, and we can find another unit for Pascal. Pascal is joule per cubic meter. This is the unit of work or energy. This is the unit of volume. So work or energy divided by volume will be pressure. Okay, these are all units of SI units of Pascal. Okay. A woman's high heels sink into the soft ground, but the larger shoes of a much bigger man do not. So again, because when the area is small, a great pressure will be exerted, which is the case here. When the area is small, a small force causes great pressure. So these high heels go into the grass, which is a soft ground here. But in this case, the weight of the man is greater, but the surface area is greater. That's why it doesn't go into the soft ground. Okay, let's do an example here. A rectangular cube of mass 5 kilogram has the following dimensions: 2 times 3 times 5 centimeter. What is the ratio of the highest pressure to lowest pressure when we put it from different sides on the ground? Okay, so we have a box, we have a rectangular box like this, 2 times 3 times 5. It's a box like this. So this is 2, this is 3, and this is 5. We have 6 sides. The largest side is this one, the top one. So because the dimension is 3 times 5. And the smallest side is this side. Let me show it by red color. Here it is. This is the smallest side. But no matter on which side we put this rectangular box on the ground, the mass or weight is the same. So what is the weight of this box? So what is the weight of this box? The weight, which is kind of force is mg. M is 5, G is said to be taken 10. So the weight of the box is 50 Newton. So the weight of this box is 50 Newton, no matter on which side we put it. If I want to calculate the maximum pressure, I need to apply the weight over area. But which area? The minimum area. When area is minimum, the pressure will be maximum. So this will be 50 over 2 times 3. You may wonder why I'm replacing the area in centimeter. So centimeter times centimeter will be centimeter squared. But I don't want to calculate the P max. Of course, I can calculate the P max in Newton per centimeter squared. It doesn't matter. The question has asked for the ratio of the highest to lowest. So I just leave it as it is. And I will go to find the P min, which is the minimum pressure. So the same weight, now this time over the maximum area. What is the weight? 50. What is the maximum area? 3 times 5. This is the maximum area. So now we want the ratio of the maximum pressure over the minimum pressure. Of course, we can have 50 over 2 times 3 over 50 over 3 times 5. Far by far, near by near, we'll get 5 over 2 or 2.5, which is the ratio of the longest side of this cube to the shortest side of this cube. Okay.